So my name is Patrick Bridges. I'd like to thank Earl and everyone else for inviting me here. I'm the director of the UNM Center for Advanced Research Computing and a professor at the University of New Mexico, just about an hour south of here. I guess some of you probably flew into Albuquerque and blew past on your way up here. If you're on Central Avenue and you see what looks like a car dealership, that's my building. So the old Gallus Oldsmobile building has been converted by UNM into our high performance computing center. And so it's a very interesting space, as Amanda and some other people that have been there can testify. So I'd like to talk today about a lot of the various things we're doing in the computational science research and education space, with a bit of a focus on the research, on the education side. And I think it's a different perspective from a lot of what you've seen, because we're not a huge center, right? We don't have multi-million-dollar budgets. We're the University of No Money. We make do with what we have. And we have lots of researchers doing lots of very interesting things. And the key challenge we face is, how do we do sustainable research computing that serves the state's research, education, and workforce development needs? So we're a research university. We have 1,000-odd faculty doing all sorts of cutting-edge research. I'll give you some highlights of the weird things people at UNM do. Kelly talked about health analytics. We're going to look at death analytics, just because it's a nice contrast. And it's going to, bother Kelly a little bit, maybe. So we have lots of people doing long-tail research. Right? So small-scale computing on hundreds of different projects that are really not what you think about when you think of HPC. We have also very sophisticated users who want to use the same systems and develop towards running on national facilities. We have national lab users who say, well, getting time on national lab machines is really obnoxious. Can I fund one of you? Can one of the students that I'm funding just do the work on your local machine so we don't have to wait through the queues? And then maybe in 6 months or a year, we'll scale up around our large machines. So we obviously have a lot going on the research side, and supporting the state's research mission is a lot of what we do. But education is a big part of where we're focusing on at UNM, and workforce development as well. So, research computing we're getting lots of push from lots of different disciplines to say, please teach our students how to use computing resources to do research. And the computer science curriculum isn't always well suited to do that, right? Most computer science departments put together computing programs to teach computer scientists to be computer scientists in 4 years, not to pick up a psychologist and give them some background that they need to do things. And so that's impacting how we're doing education. It's doing a lot of things there. And then just in terms of workforce development, a modern economy needs a broadly data and compute literate workforce. And we are not always set up as a university to develop that. In terms of workforce development, we need coherent pathways from K-12 to graduate, both state and nationwide. How many of you know about the national labs workforce development needs just in this state? Anybody? Amanda? Anybody else? Too? Gina? The labs expect 10,000 new jobs in this state in the coming 5 years at the national labs. So this isn't, fresh bachelors out of undergraduate. This is highly trained specialists going to the national labs. The national labs have a really difficult time attracting people to move to Los Alamos, to move to Albuquerque. The people that come here and live here and learn there love it and stay. But the workforce development problem is real. And it's one that we're trying to work with the labs to develop and address, but it's hard. So at the mid-scale HPC world, a lot of the traditional systems that we have always run, right, batch scheduled PBS and Slurm, are not that well suited to the workloads that our researchers want to run. So we have people that want to run MATLAB on terabyte data sets. And that's not always easy. We have non-traditional users. We have strange data sets. How do we handle data availability, preservation? Compliance is increasingly an issue. A lot of our researchers want to work on educational data sets. We want to work on studies of, on neurosciences studies. And so how you meet their compliance requirements is a challenge for us, especially when our budgets are scarce. Right? So we get lots of small-scale investments from PIs saying, all right, I have $40,000 this year. Can I get a few compute nodes? Can I get a few terabytes of storage? Yeah, I get 4 of those a year, 5 of those a year. And occasionally the institution will say, okay, here's a few $100,000 to seed something forward. But that makes it hard to support a broadly diverse workload. And the biggest problem in many cases is that support and background of the researchers is typically not very compute literate. Right? So researchers, labs, and departmental staff, if you're lucky, they remember what they learned 20 years ago when they were a grad student, and they've passed that down to their grad students who are doing what their advisor did 20 years ago. And in many cases, that's a really bad idea on modern systems. So just attracting and retaining qualified staff is very hard. So all of those I'm going to talk a little bit about the computational science research that our researchers are doing, just to sort of set the stage and the kind of diversity we're talking about. A lot of that is influencing how we're trying to design our systems. So because we can't rely on infusions of millions of dollars at a time from the state or the institution, we have to be able to build and manage and provision and run our systems incrementally year by year. And that means we have different ways that we build our systems compared to large-scale sites. And then I'll talk about a variety of things we're doing on the workforce development side, which I think speaks broadly to what we've been talking about, and a lot of what Kelly and Melissa have already mentioned. So here's an example of the kinds of things that we're doing. So we have standard things like multi-scale physics at LANL, that is my project. We have biology, nanotherapy delivery, mountain lions in the foothills of Albuquerque. Right, computational modeling of mountain lions under urban encroachment. Wind farms, economic simulations. There's a variety of things here. I'll talk about 2 of these. I'll talk about mine because it's mine, and that's my prerogative. And it's a very standard kind of national lab-oriented HPC project. The other one I'll talk about gets to the one I was talking about with death analytics, and that is we're working with the Office of the Medical Investigator. Heather Edgar is an anthropologist at UNM who also works for the state and developing a very interesting database there. So the research we're doing is LANL funded, and it's traditional HPC, right? We're trying to change how we do adaptive mesh refinement for multi-physics applications, right? And one of the goals is to support existing physics on new hardware systems. Right? And so if you know about AMR, there's patch-based AMR and cell-based AMR, sort of the standard ways you do AMR. And patch-based is really nice because you can run regular physics on patches, but patch-based has all sorts of problems with GPUs and refinement, and it gets hairy in certain cases. Cell-based is much more flexible, but has its own set of problems in terms of code that's just spaghetti with conditionals. And so we've been trying to do hybrids in that case where we do basically cell-based AMR with a regular mesh and have data structures underneath, which means we can run regular physics on an irregular mesh. And that has some benefits that we're working on. So this is all Los Alamos funded research where we can reduce the complexity of the code pretty dramatically at the cost of some memory. But code that has many fewer conditionals runs a lot better on accelerators for obvious reasons. And so the hope here, and we're starting to work on the GPU side of this, is that we'll see dramatic performance improvements as we move to accelerators. We're seeing modest improvements when we run on normal CPUs. So pretty standard kinds of things that New Mexico has done for a long time with computational science in collaboration with the labs. And we're doing this. So the New Mexico Office of the Medical Investigator is one of 2 medical investigator offices in the country that does a full body CT scan of every decedent they see. And they're making a database of all of those images so that researchers in medical imaging, in forensic anthropology, in forensics, can look and study both the data from talking to the next of kin of the decedent and look at the images and what actually happened for every decedent. So this is not a small data set. We have 15,000 full body CT scans. Each CT scan is 11,000 images. So it's a pretty interesting data set. One of the nice things about this data set is they're decedents, they're not patients. So the IRB issues suddenly become much simpler. Now, we're doing all best practices for de-identification because we don't want somebody looking at the data set and picking up the phone and calling somebody, right? But we present this data set to the researchers at forensics conferences and anthropology conferences and medical image analysis conferences. You can't get large-scale data sets like this. And so we're standing up the first one here with funding from the National Institutes of Justice. The first part is just the data set. But you talk to the anthropologists about the kinds of research they can do with it if they can construct 3D models of a huge swath of decedents and start doing feature extraction from huge imaging data sets of non-IRB controlled real people, and it becomes very interesting. So these are the kinds of research we're doing. And the systems to support it are a mishmash. So for capacity computing, we have a 300 node odd 2400 core capacity cluster that Los Alamos donated to us through a grant from NSF. So for Lano users, this was Apache. It's now Wheeler. And it's in our machine room, and it spins 100% 24/7. We have an NSF-funded system for doing more GPU clustering analysis, machine learning, big memory workloads. This is meant to support users that say, I have a terabyte MATLAB Works data set. And we're like, okay, well, that doesn't distribute very well for the analysis you want to do. Here's a terabyte of RAM. And we have Conda model, all the standard things. And our users, especially the sophisticated ones, transition to a range of national resources. They transition to Stampede 2, to TAC, to NREL, to NCAR, to DoD HPC modernization systems. Some work with national lab collaborators to execute on more specialized systems, but like I said, sometimes national lab sponsors will have the students run on our systems for development because queues on their systems are long. And that makes it a very challenging environment for supporting research. Because we can't consistently say, okay, I'm going to go spend $1 million on the next system every 3 years. So we are broadly embracing virtualization in this environment. We need to be able to build systems 4 nodes at a time, 8 nodes at a time, 20 terabytes at a time. Change how it's provisioned, change how it's allocated, and do that on a monthly basis without having to hire huge numbers of staff. Right? And virtualization has its performance costs. I have papers quantifying those. But the management ease and the ability to grow and provision incrementally is just a huge benefit for us at the mid-scale academic space. There are lots of interesting questions here. One we're looking at with NSF funding is handling compliance issues. So we need to be able to stand up environments for processing different research with different compliance needs, very simply. And so we have NSF funding exploring using virtualization to say, okay, you need this image with this software, with these compliance controls, talking to this external instrument, and meeting these compliance requirements. Spin it up, here it is, tear it down, and and off we go. We're looking at the ability to potentially be able to import external computing environments. If our PIs want to run at NREL or NCAR or on TriLab operating system machines, potentially being able to say, okay, you can get that environment and debug on that software environment locally before you go to a large national facility has some value. Finally, storage is a mess. Right? And I think everybody understands the challenges of storage in modern systems, especially when you can't invest tens of millions of dollars at a time. We're trying to figure out how to use virtualization and virtualize parallel storage systems. And so Dell, VMware, and Mellanox have been very generous with donating hardware to us for that impact, and we're working on that. And finally, the ugly secret is that we are beginning to integrate with enterprise IT units at the institution. I mean, just the simple fact of the matter is, given budgets, we cannot be standalone, IT, you're over there, here's our HPC center. And there are lots of problems with that, right? And the biggest one, one thing that's helped that is our system needs are increasingly similar. We're using virtualization, they've been spinning virtualization for a long time. The cultural differences are the problem, right? We have a culture of agility, of flexibility, of, oh, that's what you need, okay, let me open the firewall. right? They have a culture of, if the network goes down and payroll doesn't run, I'm out of a job, right? And those two are directly at odds, and figuring out how to make that work is difficult. So on education, the broader thing that we're looking at, and I'll spend the rest of the time talking about this, and it gets back to what Kelly and Melissa talked about, is that our vision is that New Mexico needs a data literate populace, right? So we have, data and compute is everywhere. And we have a population that's going to have to live in that world. And so our vision is that every person in New Mexico should be able to use data and compute to make informed decisions about their day-to-day lives. Now that's a huge, broad, oh my God, 20 years from now, maybe I can get there vision, but the goal to start with is creating educational pathways. So we have a very diverse population. We're a majority-minority state today. You could see that from Kelly's graphs earlier, with a large Native American population, a large Hispanic population, and lots of different programs that reach out to various educational points in this space. And so we're trying to integrate diverse computing research and education programs together into a coherent program. And this integration is a huge challenge. So I'll talk some about the kinds of programs we have. Jeannie talked about one that she runs here in Santa Fe earlier. That kind of thing you'll see lots of. And so there are K-12 programs that we're working with. There are general undergraduate and graduate programs. There are specialized ones that are very much in the HPC data analytics space. There are things we're doing on professional development for both HPC professionals and teachers. So K-12. These are all, the first three of these are hosted at UNM, and this is not an exhaustive list of the kinds of things going on at K-12 in the state. So the Bosque Ecosystem Monitoring Program is a K-12 program where UNM students, where UNM faculty go into schools and take students to the Bosque to do ecological monitoring. What's the rate of water flow today? Where's vegetation? Right? How high is the river? Bring that data back and analyze those data sets in their schools. Right? And this is, it has many of the challenges that Kelly raised in terms of funding. Right? They get seed funding from NSF, they do things, and then, well, there's another thing we have to fund instead. Keeping these things sustained is a huge challenge. There's a similar program on integrating mathematics and computer programming into bilingual schools. So the alumni program at New Mexico at UNM has one bilingual rural school out away from Albuquerque that they're working at integrating computational science and math into the middle school, and an urban school in the middle of Albuquerque that's also a bilingual school integrating computational thinking into those programs. One that New Mexico pioneered, many of you have probably heard of CS for All. The first CS for All program was at UNM. Right? So this is Melanie Moses' program. The way this program works is a very nice program. It teaches teachers to teach students. So we offer online courses to high school teachers in their schools to teach them how to teach their students computer science. They can come to UNM and do it. New Mexico is not a small state. We have a huge dispersed population. So CS 108 is a class for teaching high school teachers how to teach computational modeling to their students. Right? Nice programs. New Mexico Supercomputing Challenge is another one. Gutsy Girls is another one. The state has a huge array of programs at the K-12 space that are trying to serve our very diverse, very wonderful population. At the undergraduate level, right, we do things with how do we integrate computing and data science into other disciplines. If you want to come to the computer science department and let me teach them how to be a computer scientist, great. Not all of them do. Can't explain it, but not all of them do. So we're working on developing course modules, courses, data science projects to integrate into other courses. So we have some funding from DoD here. So the UNM Critical Technology Studies program is working at the sort of sophomore level to teach data science, cybersecurity, machine learning topics that students in both computer science and public policy and management and social sciences can take to integrate those topics into their regular curriculum. And the DoD funding here is funding both project development for the students and stipends to help the students stay in the program and develop. We have proposals to NNSA and NSF to expand that to other populations. And this is not just a UNM program. So this program, the CTSP program, includes Navajo Tech, Northern New Mexico College, UNM Valencia, a coalition of New Mexico universities. And we're trying to expand this coalition with the new awards we have, the new proposals we have submitted to include Southwest Indian Polytech, New Mexico State, New Mexico Tech. All of these are majority-minority institutions in the state of New Mexico. So, general undergraduate and graduate, we have issues with teaching graduate students best practices in HPC. They learned Excel like their advisor used it 20 years ago. How do we deal with that? At our center, look, here's an internship. Your advisor can pay you half time to be in your lab. We'll pay the other half. Come spend half your week with us. And we'll teach you how to use our systems to do your science. And you'll develop documentation to teach your lab mates how to do your science. And you'll go back to your lab and be the local expert on using our systems to do your science. Right? We've been doing that recently. It's worked quite well. We're looking to expand that to include data management trainings with UNM Libraries. UNM Libraries has a lot of really nice programs for doing data management, data management, preservation, publication. And so integrating data management into those trainings is something we're looking at pretty aggressively as well. We're looking at certificate programs in data sciences. I'm not going to bemoan this. We have a long history of professional development for the national labs at UNM. We have a postgraduate program where people can come back, take 4 courses, get a transcripted certificate in something related to computational science, and go back to their job. It's a very useful thing in New Mexico. It was stood up 25 odd years ago when there was some minor change that happened between Cray and clusters or something that I've forgotten about. And there's specializations there we're looking at in data sciences, CFD, quantum, and maybe an online program because it's postgraduate, because it's many people who are returning to work online, has a lot of attractions there. So we have all of these point programs. And so I'm going to finish with one set of things that's really the main problem here. So I've shown you a lot of education programs that are going on in New Mexico that solve a particular problem with a particular population at a particular point in time. None of these are tied together, right? And as a computer science faculty member, what I see when I start looking at what happens to students is I'll say, okay, well, look, we had this population of students that went to the supercomputing challenge, right? Their teacher took CS for All, they learned computational modeling, they did supercomputing challenge in high school. Where'd they go for 2 years? Okay, well, here's 3 of them that turned up in our junior level classes after they got past the pre-major, and we saw them again. Right? But there are these gaps between these programs where they go to this K-12 program and maybe that K-12 program and maybe that internship, but there's no longitudinal tracking of them, there's no longitudinal mentorship of them, and we lose them, and they leave the discipline, they leave the state. We don't know what happens to them, and it's a huge problem. The K-12 to undergraduate transition is the worst one, but the undergraduate to graduate one, things happen there as well. Internships are a reasonable mechanism for doing that, but we really have to have some kind of longitudinal support for these students, and we don't have it right now. It's a huge problem. Near-peer mentoring is a good mechanism there that we're starting to look into. If our sophomores were mentoring high school seniors, right? If our new graduate students were mentoring, college juniors, right? So that those juniors knew what it meant to be a graduate student. Right? If lab staff were mentoring our graduate students consistently so they knew what the job would look like when they got out. We really have to, and this is a huge challenge for the state, I'm going to stop here, provide multiple well-defined pathways through existing programs, longitudinally tracked for all of our students. And the final thing I'll say is to emphasize Kelly's points. Each of these programs has a sustainability problem, especially the K-12 ones. The ones that get to the undergraduate and graduate level where we have faculty who are teaching those courses, the university, we can beg, borrow, and steal the resources to do that in our departments, even though that's hard. The K-12 ones where we're reaching out from the university to the local schools, we get one-time funding for a few years from NSF to start those, and then then a miracle occurs. We've all seen the blackboard, right? And then workforce comes after the miracle. Right? If you guys want to be the miracle, that would be fabulous because that's where the problem happens. And so, Kelly's told you about the great program she's doing. Melissa's told you about the great program she's doing. I'm sure we'll hear about another great program next. Keeping these things up and sustained and working together integrated is the fundamental challenge for education and pipeline and workforce development, in my opinion. And so I'm going to stop there. If you have any questions, I have an email address, I have cards. I'd be happy to talk to you afterwards. If you want to swing by Albuquerque on your way down to the airport and chat for a while tomorrow, I'm around. And I'll stop there. Thank you. And I did get my Mississippi State lanyard out for Kelly, so the mafia is eternal.
Do we have any questions? Yes, that's mine.
Yeah, we talked to some other universities about this topic, and about integrating some basic HPC competency into the curricula for at least for engineering and science majors. Mm-hmm. And they say, well, we really would love to do it, but there are so many requirements, we can't fit any more in.
Right. Yeah, so that's definitely a problem. The upside, and I think one thing that helps us there, is that we're starting to, by us I don't mean New Mexico, I mean computer science writ large, is that we're starting to increasingly integrate parallelism earlier and earlier into the curriculum because we have to. So that students are seeing, in maybe their second or third computer science class, threads and synchronization. Right? Distributed programming, yeah, that's still an issue. We teach an undergraduate HPC class. Both math teaches a scientific computing class. It's a senior level elective. We teach an HPC systems class in computer science. It's a senior level elective, right? And it's a senior level elective, and our CS students have a budget of 3 of those, right? So we've been told and we've been required to reduce our curriculum down to 120 credit hours. 120 credit hours with a 20-odd credit core and the math our students need and software engineering and algorithms and data structures and operating systems and programming. We have space in our curriculum today for 3 to 6 electives. I would love to, and we do teach the HPC electives and they do get enrolled in, but it's one of 3 to 6 our students take. And there's 0 sum on faculty. If we teach that class, there's some other topic that we're probably not teaching because we only have so many faculty, which is probably the bigger problem, to be honest. Thanks. Okay.
So this is a pretty broad question. At the national level, might you have any recommendations to what the Department of Education and the National Science Foundation should be doing differently?
Consistent funding for programs is a huge problem. Or providing some way to sustain the programs that we stand up is something we need. NSF wants us to have sustainability plans when we submit these proposals, and we try our best. But sustaining those programs is hard. The other one, anything we could do, especially with the Department of Education on longitudinal tracking, would be a huge thing. Because when I look at this as a faculty member at our enrollments and what the university gets, I know what happens to our students. I can track cohorts, and we have the analytics of this many students came in, and they went to these pre-majors, and they went from there to these majors. I don't know what programs they went through before. And in many cases, I can't because it's student data, right? And I don't know where they went after, right? One of the fights we have with UNM is we want to make sure they have a UNM email address forever, because that means we can always contact them. UNM would love to turn their emails off after 6 months because they're not at UNM anymore. Why would you want those? Right? So any way we would have of actually doing longitudinal studies of where do our students come from, what was their background, what programs have they gone through, given that, how did they do at UNM, identifying them early so we can provide them the students who are most likely to want to go into our discipline, to support them well, right? Tracking them afterwards to actually look at outcomes, right? The only way we get outcomes today is by hoping they respond to emails to an address they may or may not look at or even have anymore to get back on our surveys, right? So how do we track outcomes? That would be, some way of doing that would be a huge help.
Gee, it seems that they would want to track alumni for donations.
Yeah,
And therefore keep their email addresses active.
I mean, departments do all sorts of interesting tricks there. I know departments that have given students extra points and assignments if they follow the department on Facebook, because that lets them contact them on Facebook after they graduate. Right? Yes, an alumni would love to do that. But the alumni divisions at most universities, the foundations, tend to be relatively independent from the rest of campus. And they guard their contact database like it's the crown jewels. Because they wouldn't want, us filthy academics talking to our alumni and figuring out,